Hello ladies and gents, welcome to another repair video. Today we're going to be working on this Nintendo Switch which has been sent in. This particular console has been sent in because it has a damaged volume button connector. So this is one that I haven't really come across before. Obviously a connector is just a connector, but apparently the volume button connector is damaged. Like I said, it's not going to be a common repair because these really don't get damaged that often. So obviously this is some sort of technician damaged, but I'm not going to worry about trying to turn it on and testing it. I'm just going to open it up and basically just see what's going on with it. So we'll open it up, take a look inside, and then replace what needs replacing. So while I've got your attention, if you are new to the channel, be sure to hit that subscribe button and turn on the bell notifications so that you're notified every time that I upload. So let's get rid of that. And let's take that off. Okay, so just judging by the position of the speaker wire here, I can tell that someone's been in here. Just by the way, that's been routed, so I'm going to disconnect that straight away because it's routed incorrectly. It's supposed to go underneath the battery connector, or battery cable rather. So I'm going to take the heatsink off. That's already torn. A little hint, if you use a little bit of hot air on these foam things here, it'll actually come off in one piece and then you can just stick it back down because the adhesive on the bottom of the heatsink itself stays intact. So just a little tip there, a little pro tip. So let's get the LCD connector and the game card reader disconnected just so I can take a look around. Okay, and I mean the volume flex doesn't look damaged, which is kind of odd. Okay, I think I'm going to need to test this. The flex for the volume connector doesn't look damaged, so it's the top connector, the top white connector. That doesn't look damaged at all. So, yeah. Let's have a look under the microscope. Let's see what's going on. Right, okay, so is that just not going in all the way or what? Maybe. Little bit odd. So it doesn't actually look damaged. Let's disconnect the fan. Okay. Right, so now I can take a proper look at this then. So if I just disconnect this. I can see it's not actually in. Right, so well, that looks bent for a start, but it doesn't look damaged as in unusable. Odd. Right, so let's lift that up. So is it just the flex or is it the actual connector? I'm not sure. I'm not sure at all. Right, so what I'm going to do then, I've got a donor board here, which is probably where I'm going to be taking the connector from. So this is one of my own boards, one of my own donor boards. Let me just see how this sits inside here. Right, so that lines up, seems to line up okay. It seems to line up okay. Right, so I've got some thermal paste on my finger, so you'll have to excuse that. That's come off the Nintendo Switch. So let's see how it lines up on this one then. I can see, yeah. Okay, so it's not lining up. Okay, well, that should be fine then. Okay, so what I'm going to do then is just remove the motherboard from the chassis. Okay, so let's get that LCD out. Okay, so now I can unscrew the motherboard and remove that from the housing, just to be able to work on it safely without melting plastics on the chassis and things like that. We don't really want to be doing work inside the housing. I have seen a few videos from other people in the past, and more specifically someone covering an orange screen of death, where they reflowed the Wi-Fi IC while it was inside the housing, which is a big no-no. And I wasn't happy at seeing it, to be honest. Okay. Let's just remove the speaker. There we go. And we're ready to roll. Alright, so what I need to do then is I need to remove the connector from the motherboard. So the way I'm going to do that, I'm going to actually remove it from this one first, from this donor board first. I'm actually going to use this donor board, in fact, because I've already removed quite a few connectors from this board and quite a few things. So I'm going to remove it from this one. So what I'm going to do is I'm just going to basically lay the board on top of this aluminium BJ reballing jig, and I'm going to use my hot air from underneath the motherboard. And the reason for that is because if I use hot air around this area here from the top, it's going to melt the fan connector and probably the connector for the digitizer and game card reader. So basically what I'm going to do is just heat up from the bottom. And this is where the angled nozzles will come in handy as well, because we can obviously have the hot air gun sideways. So that's where they'll really come in handy. One thing we do need to be careful of is there is a BGA chip on the other side, but unfortunately there's not a lot we can really do to actually protect that, because if we put Kapton tape there, then it's going to reflect heat going through to the board. So there's not really a lot we can do. Now, I'm not bothered about this specific motherboard. This specific motherboard is completely dead, hence the reason there's no CPU on it. So I'm not bothered about this one, but I'm not going to remove the connector from the board we're working on using the same method. Okay, so that connector's removed. I've got that connector safely here. So I'm going to move that motherboard out the way, and I'm going to move the stand out the way as well. I could use a board holder, but I need something high up, so without using a helping hand, you know, one of those adjustable arms, really there's not a lot I can do. So I'm going to put that connector just there, nice and safe. And I'm going to go back under the scope. Okay, and like I said, I want to remove this connector safely. So what I'm going to do is I'm going to remove it using the soldering iron only. So I'm basically going to just butcher this connection and remove it as safely as I possibly can, really. So you'll notice I've just added some flux there. I'm not sure if I mentioned it on the camera or whether I just did it instinctively. But I've just added some flux, and the reason for that is because I'm going to replace the solder that's on here at the minute with some leaded solder, just to lower the melting temperature a little bit so that we don't damage the pads while we're removing the connector. And this is going to look really aggressive when I actually do it, but it's really not that aggressive. It's aggressive in the sense that, you know, we're actually choosing this option to remove it. But at the same time, like I said, I want to protect that BGA chip on the bottom. So I'm basically just going to add some solder and remove the connector by melting it out. So the reason I'm adding leaded solder as I go along, like I said, it lowers the melting temperature and makes it a lot easier to remove the connector. And yes, like I said, it looks aggressive, but it's probably the safest way, because we don't care about this connector. This connector's being removed anyway, so we really don't care about damaging the connector at all. All we want to do is just remove it as safely as we possibly can. So I'm just basically going to melt the connector until the area is clean. I might end up knocking a couple of caps off here. Right, I'm just going to clean up that little bit there. Okay, and now what I need to do is just clear away the bits of plastic that are on the actual pad itself, and the way I'm going to do that is by just using a little bit of solder wick, and hopefully that'll scrape the pads enough to clean them up. So you'll notice I'm going with the direction of the pads as well. I'm not going against the direction. It's like shaving your beard against the grain, it's going to hurt. Alright. So I'm just going to clean that up then. And the way I'm going to clean it up is by using a bit of isopropyl alcohol and a toothbrush. Just give it a nice scrub. Okay, and you'll notice that we've got some gunk on the ground plane here. So this one here looks like it's a ground plane. So I'm just going to give them a scrape with the tweezers now, just clean off any excess plastic that's there. And it looks like I have lost a component. I think that's probably a resistor. So I'll sort that out. I'll get one off a donor board and I'll replace that. Alright. So what I'm going to do now then is just add a little bit of flux. And I'm just going to pre-tin the pads just to get rid of any oxidization and things on the pads. And also to prep them ready for the connector. There we go. Perfect. So now that's done, I can pop this into position and get it ready to solder onto the board. So it's going to go just there. Let's just line that up and hold it in place. Okay, so that's lined up. I am going to need to add some heat to the board, and the reason for that is because basically I've got no way of flattening it down without removing the solder and trying to solder it without solder on the pads before I put the connector in place, which is rather difficult. So I'm going to need to heat it up a little bit, but there is leaded solder on this now, so it shouldn't be a problem. It should melt a lot quicker than the lead-free solder that's on the BGA chip underneath the board, so it shouldn't be a big deal now to be able to use some heat around it. But what I need to do first is just get the replacement component. I believe it's probably a resistor. If it was a capacitor, I wouldn't be too bothered, but I believe this is probably a resistor, so I'm going to get that. There we go. That was easy. Okay, so I've got the component in place. I'm going to tack it down with one side, and then when I do use some hot air, it's going to flow itself into place. So I'll basically just tack it down with the soldering iron. It doesn't have to be actually soldered, it will flow down. And now I'm ready to use a little bit of hot air just to flow the components into place, so the resistor and the connector as well. So obviously I don't want to use hot air for too long, so I want this short and sweet, because like I said, I am worried about that BGA chip underneath. So short and sweet. So I'm going to keep a very close eye on the connector itself. Should not take long at all. Something just fell then. I wondered what it was. It was just a little bit of plastic. So thank goodness for that. Okay. So like I said, short and sweet. So now we can have a look at the situation under the scope again and see if we've done the job. And I believe we have. It's a little bit slanted, granted, but it looks like it's on there nice and solid. I'm not bothered about it being a little bit slanted. I would rather it be slanted than not have it on there. Actually, maybe not. Maybe not. There's a little bit of it's a little bit misaligned. I don't know if that's going to be making a connection or not. So what I'm going to do is just clean it up, and then I'll add some fresh flux and just reflow it again real quick. So I wouldn't be bothered if it was a little bit slanty, but I can't have it misaligned and have it have a chance of not being connected properly, because then we're just going to be in the same situation. It's not going to make contact, and we're not going to be able to adjust the volume or turn it on for that matter. So it's got to be at least aligned. Although it's not far off. But no, I'll reflow it. So I'll add some more flux around there, just a little bit. There's still a little bit more plastic stuck there. Okay, so let's let that cool down. Fingers crossed it's done this time. Alright, so no damage to that connector there. The resistor looks like it's in place. Let me just give that a little nudge. Could do with a little touch up on the resistor. Yeah, that seems like it's making contact. I can touch the pins up anyway. So I'll just add a little bit more flux there, and I'm going to switch to a smaller tip. Let's just touch up the resistor. And a little bit of a bridge there, but I'll deal with that in a second. just realised I've dealt with that bridge off camera on the resistor. Okay, that should be good enough. So, might have been a little bit out of focus there, but it's fine. So, I'm going to clean it up with some isopropyl alcohol, and then hopefully we can give it a test. Okay, let's dry that off. And let's take a look. Yeah, that might be okay. Okay, right. Let's give it a test then, shall we? Alright, so I need to pop it back in the housing. Okay. Now time for the moment of truth. I'll tell you what we'll do. We'll pop under the microscope and check that. So let's just take a look at this connector now. Let's see if it goes in. There's a bit of flux inside there. And yes, it does. So that goes all the way in now. There is still a little bit of flux in there which I'm going to need to get out. So you can see on the connector now that we've got flux on it. So obviously if we don't get that off, because this is not no clean flux, we will run into issues later on in life. Probably in around about 3-4 months when it starts to corrode the board. So we're going to need to get that out now. That's more like it. Okay, so the isopropyl alcohol, that will evaporate. I'm not really fussed about the IPA. IPA evaporates with heat, so I can just use some hot air around it. Or warm air. Just like that. Just a tad of warm air. And there we go. To be honest, it might be a good idea to replace the ribbon as well. Maybe. I'm not sure. Let's test it out. I'm going to put it back together enough for testing. Connect up the speakers because that's part of the testing process. And remember what I said about the speaker being underneath the board and underneath the battery connector? Well, I'm going to reroute it now. So basically, with the cable underneath the battery connector, what that will do is it will secure it down and stop it getting trapped. Before I go ahead and turn it on, I'm going to connect up the fan, or rather screw the fan in at least. Reason being is because I can screw down this part of the motherboard, and if it all works, then I've got no reason to disconnect the digitizer again. So if I do that now, then it saves me having to do it later on. So let's just replace the thermal paste. And before I forget, let's pop this screw in here. There we go. In fact, I might as well just screw the entire board down. It's only 4 screws, it's not a big deal if I have to remove them again. Another pro tip here, move the speaker cable out of the way while you're screwing the screw by the battery connector in. Because if that gets trapped, you're going to end up with a audio IC error code on boot up. Okay. So let's add some thermal paste. And whoops, I almost connected that up without connecting the digitizer up. There we go. Let's just secure that in. I'm kind of putting it pretty much all back together, to be honest. But we can't risk damaging it while we're testing. If we damage it while we're testing, whatever we damage, we've got to fix. So I would much rather just screw it in enough to protect it while we're actually testing it. And I'm going to screw the USB port down as well. Once again, more for protection. Okay. It's kind of back together. I mean, to be honest, they don't take long to take apart, so it doesn't really matter too much. I'm not going to put the case on though. Okay, moment of truth. Let's see if the power button is going to turn it on. Yes, it is. So the power button works. Hopefully the battery is not dead. Touchscreen works. And volume works. Awesome. Okay, that's pretty much it. So, yeah, I'm happy. And audio works as well. Okay, so yeah, that's pretty much the job done. So all I've got to do with this now is just literally put it all back together. But I mean, for the sake of the video, I might as well just put it back together now. I don't generally put them back together on video, but you know, just for the sake of how many screws there is left to put in, I may as well do it. But yeah, happy days on this one. Nice straightforward job there with the connector. I mean, it's not straightforward. It's certainly not something that everyone's going to be able to do. But you know, if you actually stop and think and use a little bit of your thinking to determine what the potential issues are going to be, then you're not going to run into as many issues. And that's what it's all about as a technician. We need to analyse the situation and find the best solution and the safest solution for the repair. So I'm just going to finish putting these screws in. Okay, and the back cover. And I've got to test the game card as well, just because the well, we've had hot air around the game card reader connector, so I've got to test the game as well. Whoops, keep forgetting these are not magnetic. So yeah, there's another pro tip actually. These screws, the ones that go in the bottom of the plastics and the top plastics, the little Phillips screws, they're non-magnetic, so don't get them mixed up with the ones that are on the board, because the ones that are on the board are magnetic, and obviously Nintendo has made them non-magnetic for a reason. Now what that reason is, I don't know, but they've been made non-magnetic for a reason, so just try and not get them mixed up when you're putting it back together. These ones are, though, strangely, the ones that are on the Joy-Cons, or the Joy-Con rails, which is kind of odd considering the analog sticks use a potentiometer, so it's kind of odd that they would use magnetic screws there, but not around the middle where the fan is and the USB port. But I'm not an engineer, so I'm not sure. I don't have a clue. Never mind. Okay, I'm going to test a game quickly before my throat completely goes, as you can probably hear. Okay, cool. So let's just test the game. So we've got Pokemon Sword. And typical. There we go. Okay, so yeah, that game's in the workshop, so bound to have a little bit of gunk on it. Yeah, so it's reading the game. Let's see if it's actually... no update is available. How do you know? Right, let's play the game, and it loads. Cool. Okay, so that's good enough for me. So yeah, let's just summarise on this then. So this was sent in because it had a damaged volume connector. Now obviously I didn't verify the issue first, but by looking at the actual connector itself, it clearly wasn't going in properly, and that was obviously going to be causing a problem for the volume connector or that flex cable making a contact with the pins on the board. So you know, by replacing that connector, yeah, it took a little bit longer than it would normally for any normal connector, but you know, it is what it is. It's a very dangerous area to work in. We do have to take a lot of care on that particular area because of that one BGA chip on the bottom of the board, and also the other connectors around that one connector. If it was just that one connector on its own, wouldn't be too much of a big deal, but unfortunately these are really compact little consoles and the connectors are all over the place. But that's going to be for this video. Thank you very much for watching. Let me know what you think down in the comments down below. As always, if you want to see more repair videos, be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. If you want to organise your own repair, you can get in touch by using the contact details in the video description, and if you drop me an email, I will get back to you with an estimated quote and information on how you can send the device in to me to be fixed. I do work on Xbox Ones, PlayStation 4s, Nintendo Switches, PlayStation 5s, and Xbox Series S and Series X. So, yeah, whatever console you've got, as long as it's this gen or last gen, I'm more than happy to work on it. But that's going to be it for this video. Thank you very much for watching, and until next time, see you later. Bye for now.